In this video, I'm going to be doing some product and quotient rule examples and working through BC Homework 2.2. So let's get to work. Let's look at this. What do we got here? Okay, first set of problems, find the derivative of the given function. So looks like, all right, I'm going to just right here, before we start, remind you of what you recently learned about. You know, maybe it wasn't today, it was today for me, because I'm just going to record this right after school. But, okay, the derivative of, yep, I'm in the shot. The derivative of f times g is equal to, well, we take the derivative of one, leave the other one the same, and take the derivative of the other one and leave the one the same. Okay. And then derivative with respect to x of something like top over bottom is going to be bottom times the derivative of the top minus the top times the derivative of the bottom, yes, divided by bottom squared. So I won't be able to keep that up at the top of the screen the whole time I'm working these problems, but you know, long enough that you see where I'm coming from. So the derivative, I'm going to take the derivative of x to the 3, and that's going to be 3x to the 2, and then I need to leave cosine of x the same. Now I'm going to add in, leaving x to the 3 the same, the derivative of cosine of x. And the derivative of cosine x is negative sine x. So I'll have minus x to the 3 times sine x. Okay. Over here, x sine x is going to be very similar. dy dx. I'm going to take the derivative of x first and leave sine of x the same. Okay, plus leave x the same and take the derivative of sine of x, which is cosine x. All right, here we've got ourselves a quotient. So if we're going to take the derivative, we need to be using the quotient rule. So f prime of x is bottom times the derivative of the top minus the top times the derivative of the bottom. Okay, the derivative of the bottom is going to be 2 because the derivative of 2x is 2 and the derivative of negative 3 is 0. Okay. All divided by the bottom squared, so that's 2x minus 3 squared. And, you know, maybe there is something we could do to simplify this. It looks like I've got an x to the third and more x to the thirds over here, but you don't have to, and I'm not going to. So the next one, I'm going to say, okay, f prime of x is bottom times the derivative of the top. The derivative of 1x is going to be 1, minus the top times the derivative of the bottom. The derivative of 1 is 0, and the derivative of negative 1x is going to be negative 1, divided by the bottom squared. Okay. Leave that for a second while I'm working this one. G prime of x is going to be, okay, bottom times the derivative of the top. The derivative of sine of x is cosine x, minus the top times the derivative of the bottom. Well, the derivative of the bottom is just going to be 1. And divided by the bottom squared. All right, one more time. G prime of x is bottom times the derivative of the top minus top times the derivative of the bottom, divided by the bottom squared. Square sine of x, we get sine squared x. All right. Now, here we go. H. This is one where if you really felt like, hey, man, I would rather distribute this thing and use the power rule, you can just go right on ahead. I actually think, though, that for me, since we're not going to need to do anything with this after we take the derivative, I think I'm going to just use the product rule, right? It's our shiny new tool that we just learned about, so we might as well use it, right? But you would be, it'll look different. Your solution will look different. Your derivative will look different if you distribute, combine like terms, and then take the derivative using the power rule. But it's going to be the same function, I promise. And you could go in and do some algebra and verify that. Anyway, x squared minus 2. The derivative of x squared is 2x. The derivative of negative 2 is 0. Then I'm going to leave this thing the same. Then I'm going to add in, leaving x squared minus 2 the same, taking the derivative of this piece. And so I'll have 4x to the 3 plus 8x to the 1 minus 3 plus 0. Okay, so, and that'll be a suitable formula for h prime, at least for our purposes, right? Especially we're here to practice the product rule, so we're going to just stop there. All right, another one's bleed through so bad. Oh, right. If y equals x squared tangent of x, find the value of dy dx at the point where x equals pi over 4. Okay, well, we're going to use the product rule. So I take the derivative of x squared, that's 2x. Leave tangent the same. Okay. Then I'm going to add in, leave x squared the same, and take the derivative of tangent x. Okay. One thing that I may or may not have shown you during class, depending on which class period you were in, was that the derivative with respect to x of tangent x is secant squared x. Okay? If you don't believe me, if you need like some verification of this, what you're going to do is you're going to, off to the side on a separate sheet of paper, turn tangent into sine over cosine, use the quotient rule, and then remember that sine squared x plus cosine squared x always equals 1. Okay, and then you'll get that, and it's not too hard. Definitely something you could do. So derivative of tangent secant squared, that's where I'm going to get this secant squared x from. All right, at the point where x equals pi over 4, that's going to be 2 pi over 4 times the tangent of pi over 4. Okay, maybe you aren't going to be remembering what the tangent of pi over 4 is, and that's all right. Okay, pi over 4 is the one that's a 45-degree reference angle. I'll draw myself a little triangle. And that's going to be a 1. And with the 45, 45, 90 triangles, that's 1, that's root 2 over 2. This is also root 2 over 2. And since SOHCAHTOA, tangent is opposite over adjacent, these look like the same. So if I divide them, it's going to be 1 plus x squared is pi squared over 16 times secant squared x. Well, I'm just going to find secant x and square it, right? Like, you don't need to actually do the squaring, right? We just need a number. So secant is the opposite of cosine. Cosine is this over 1. So secant will be 1 over root 2 over 2. So I'm just going to call that 2 over square root 2. Right? 1 over a fraction just effectively flips the fraction, so I'm happy. That's the value of dy dx at the point where x is pi over 4. All right. Find the value of f prime of 1. We can do this. All right, we're going to take the derivative using the quotient rule. Bottom times the derivative of the top. Derivative of 1 is 0. The derivative of e to the x is e to the x. Minus the top times the derivative of the bottom, which is 1. The derivative of x is 1. Divided by the bottom squared. F prime of 1 is going to be whatever I get when I plug in 1 here. So this is going to be 1 e to the 1, that's just e, minus 1 plus e, divided by 1 squared. Well, when we look at that, that's going to be e minus e, and it's going to end up being just negative 1. Okay, that's interesting. I wouldn't have suspected that would come back with an integer answer. All right. G of x is log of x divided by 2x minus 3. Find the value of g prime of 1. Okay, you can do that. G prime of x is equal to bottom derivative of the top. The derivative of natural log x is 1 over x minus top times the derivative of the bottom. That would just be 2, because the derivative of 2x is 2, and the derivative of negative 3 is 0. I feel like we encountered this type of object before, but what even was that? What really happened? Yeah. Oh, yeah, it had a 2x minus 3, number 3. Not crazy. So, bottom squared. Okay, I plug in 1. So that's 2 minus 3 is negative 1, times 1 over 1 is negative 1. Minus log of 1 is 0, divided by, well, negative 1 squared is 1. So that's going to be negative 1 again. Okay, that's interesting. Also, hold on, log of 1 equals 0. Wait, no. I'm thinking e to the special power equals 1, right? And I'm thinking, what exponent do I put in that box to get that 1? And that's going to be 0. Okay. Now, write the equation of the line tangent to the graph of y equals cosine x divided by x at the point where x is 3 pi over 2. Okay. So, y prime, bottom, times the derivative of the top, minus top, times the derivative of the bottom, divided by bottom squared. Okay. I'm going to need that. I need first a point, though. I probably should start with that. X is 3 pi over 2. Y is cosine x. Okay, well, divided by x. But cosine here, that's 3 pi over 2. Cosine's the x-coordinate. That's going to be a 0 x-coordinate. So it's 0 divided by 3 pi over 2. Well, that's going to be 0. And then the slope, I'm going to get from y prime, and I'm going to plug in 3 pi over 2. So 3 pi over 2 times the negative of the sign, negative 1 is going to be positive 1, minus the cosine of 3 pi over 2, we're feeling like that's 0, divided by 3 pi over 2 squared. Now if I have, like, say, x divided by x squared, that's like 1 over x. So I'm going to say that this is going to be 1 over 3 pi over 2, 1 power of 3 pi over 2 in the denominator. And then that'll effectively flip the fraction, so it'll be 2 over 3 pi. And now I'll be ready to write my equation. It'll be y minus 0 equals 2 over 3 pi times x minus 3 pi over 2. All right, and that's cool. All right, write the equation of the line tangent to the graph of this at the point where x equals pi over 4. Okay, well, I need a point. X equals 4. Y equals, the square root of 4 is 2, divided by 4 squared is 16 minus 12 is 4. Okay, I didn't need that much room. Okay, so that's 4.5. The slope, I'm going to need y prime, so I'm going to say bottom. Derivative of top. Okay, the derivative of x to the 1/2 is going to be 1/2 times x to the decrease the power by 1, that becomes negative 1/2. Minus the top times the derivative of the bottom, divided by the bottom squared. Oh, I don't think I mentioned this in any of my classes, but a common mistake that people make when they're first starting to do the quotient rule is actually squaring this thing. And that's just almost never the thing to do, because, you know, generally it's probably easiest for us to deal with a factored form of something than unfactored, especially if we're trying to find where it's 0, and I don't know anything else. Trying to just evaluate it. You'll see here, if I just, well, I've already done this evaluation once, right? I just determined that that was 4. So I can say that the denominator is definitely going to be 16, but that's, we'll get there. All right, slope is x squared minus 12 is again 4, still 4, times 1/2 times x to the negative half. Well, x to the negative half is 1 over the square root of x, so that'll be 4 like that. Minus the square root of 4 is 2 times 4 is 8, divided by, 4 squared is 16 again. Now, if I take, this is going to end up being what? 4 in the denominator, divided by 4, okay, 4 divided by 4 is 1. So 1 minus 16 is negative 15 divided by 16. Okay, so my equation is going to be y minus 1/2 is equal to negative 15/16 of x minus 4. And then the horizontal tangent question. All right, horizontal tangent, we see that, and we know that means that we are looking for a place where the derivative equals 0. Right? Because the horizontal line has slope 0, and f prime of x represents the slope of the tangent to the graph of f at any point x. So we need to just take f prime, and did we already take the derivative of this thing? I'm pretty sure we did. X minus 16 of the denominator? Nope, doesn't look like we have. Okay, whatever. So, f prime is bottom times the derivative of the top minus top times the derivative of the bottom Okay, derivative of x is 1 and the derivative of negative 16 is 0, divided by the bottom squared. All right, and in this situation, when we need to find the zeros of the derivative, okay, I'm going to have to do this here, because the only way that this is going to equal 0 is if the top is 0. Okay, so I'm going to say this becomes, all right, 2x squared minus 32x minus an x squared. Okay, so I've got this f prime equaling 1x squared minus 32x divided by x minus 16 times x minus 16. And if I'm interested in why this is equal to 0, I'm going to need to factor the top. Okay. And this equals 0. I mean, you could set up a proportion, cross multiply if you were just really unsure about what's going on here. But this is going to happen when x is 0 or when x is 32, because that'll make the top 0. And those are the x values at which the graph of f has a horizontal tangent. Bring in the third page. All right. Suppose f of x is 1/24 of x to the 6th minus sine of x. Find the value of f's fifth derivative at x equals pi over 2. Well, I find myself doubting that there's enough room for me to do that, but maybe I will. Okay, so f prime is going to be 6 over 24, it's 1/4, x to the reduced power by 1. Derivative of negative sine is going to be negative cosine x. F double prime is going to be 5/4 x to the 4. The derivative of cosine is negative sine, so the derivative of negative cosine will be positive sine. F triple prime, I'm going to multiply by 4 and reduce the power by 1, so that'll be 5x to the 3, plus the derivative of sine is cosine x. Okay. F's fourth is going to be 15x to the 2 minus sine x, so the derivative of positive cosine is negative sine. Then finally here, the fifth derivative is going to be 30x minus cosine x. All right, and at pi over 2, that's going to be 30 pi divided by 2 minus the cosine of pi over 2. Pi over 2 is right there. The cosine there is the x-coordinate is 0. And that's going to be f's fifth derivative at the point where x equals pi over 2. All right, write the derivatives of tangent, secant, probably cosecant, and cotangent, right? I'm not going to ask you to write the same thing twice. That doesn't make sense. It just said right, but what I will tell you is that if you need support on why these are true, it's all quotient rule. So tangent, you find it with sine over cosine. Okay, so if y prime equals secant squared x, y equals secant x, y prime is equal to secant x tangent x. Okay, now as far as the co-functions for these guys, cosecant x, if you're ever having a hard time remembering what to do, I mean, you kind of got to know these, but just like sine to cosine, right, you make the derivative of the co-function and you make it negative. I may have mentioned that. But that'll be, all right, so it'll be negative cosecant squared x. And this will be negative cosecant x cotangent x. And with these, if you want to find out why these are true, you're going to do the quotient rule with the top being 1 and the bottom being cosine x, with the top being 1 and the bottom being sine x over here. Okay, and that will show you why these rules are what they are. You know, you might have to apply a trig identity, which is not something you absolutely have to do in AP Calculus, but you know, if you're the type of person that's just that curious, then I don't know, you might just need to do that yourself. All right, so now we're going to do some table problems. And there aren't any graph problems on this assignment, and I'm going to have to go after I'm done with number 19. So I'm going to record the extra practice problems as a separate video. And that set has a lot of graph and a lot of table on it. So if you're needing more of this, go find that extra practice there. Okay? And that'll be labeled, more product and quotient rule practice on my channel. So anyway, h prime of x. Okay, when you see this is something I don't think we dealt with in class, 2g times f. What I recommend doing is just, instead of looking at this as the product of three things, or just factoring out the 2 and dealing with it later, just make the first factor 2g and the second factor 1f. I feel like that's the way to go. So I'm going to take the derivative of 2g, and that's going to be 2g prime, leave f the same, plus leave 2g of x the same, and take the derivative of f. All right, then h prime of 2 is going to be 2 times g prime of 2 times f of 2 plus 2 times g of 2 times f prime of 2. And then I'm just going to grab all these numbers from the table, and it's going to be great. So 2 times g prime, so that's going to be 2. G prime of 2 is negative 1. F of regular 2 is 4. Plus 2 times g of 2 is 3. And f prime of 2 is negative 2. And that's a safe place to stop. All right, quotient rule. Bottom, derivative of top, minus top, derivative of bottom, divide by bottom squared. All right, so k prime of 3 is going to be f of 3 times 6 minus 3 squared is 9 times f prime of 3 divided by f of 3 squared, which is going to be, all right, I realize I've gone off the shot. All right, there you go. F of 3, that's 2 times 6 is 12, minus 9 times f prime of 3 is minus 9 times negative 3 is plus 27, divided by f of 3 squared, that's going to be 2 squared. Okay, so 39 over 4. It's a nice rational number. And then, okay, g divided by f, just like I probably told you in class, like I'm hardly ever going to ask you about f divided by g, because most people, if they're wrongfully memorizing the quotient rule in terms of f and g, they're going to have it memorized, the derivative of f divided by g. Okay? So I'm going to always ask you about g divided by f. Just make sure you know the quotient rule and you just don't have like this kind of saying with f and g memorized. Okay? I won't stick with you, right? That's why I'm not really in favor of just memorizing stuff and instead just learning how to do it. It's because that'll stick with you longer. So q prime is bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. Q prime of 4 is going to be f of 4, which you're going to have to just believe me or look on your own sheet and see it's 3, times g prime of 4 is negative 3, minus g of 4 is 2, and f prime of 4 is negative 4. And we're going to divide by f squared, so that's going to be 3 squared. I'm going to just make sure that I've got that right. F of 4 is equal to 3. I'll square it. That'll be 9. And that's, again, safe place to stop. So it's negative 9 plus, so I think it's negative 1/9. Either way, doesn't matter. That's it. Okay, now we're going to find p prime. That's going to be, take the derivative of g, leave cosine x the same. Then I'm going to add in the derivative of cosine with keeping g the same, but I know that the derivative of cosine is negative sine, so I'm going to make that minus g of x sine x. Meaning that p prime of pi is g prime of pi times the cosine of pi. And I don't know, maybe you need a little support on that. Okay, pi is over here. Cosine is the x coordinate. That's going to be negative 1. Minus g of pi times the sine of pi. Well, that's the y coordinate over here. That's going to be 0. Okay, so that's one less thing to worry about. And, okay, I'm going to go up and look at g prime of pi. That's negative 4 times negative 1 is 4, and that became 0 because I multiplied it by a 0. Right? And that's the entirety of homework 2.2. But again, if you need more practice or you're looking for the solutions to the extra practice for product and quotient rule, that's going to be in a separate video. That's all I got for you.